Good morning, student. Welcome to TYBSc Analytical Chemistry class. I am Dr. K.R. Labhade, Associate Professor, Department of Chemistry, S.V.K.T College, Devdali Camp. Recap of last lecture. During last lecture, we have discussed gravimetric analysis. In that, we have seen definition of gravimetry. Gravimetry is the process of isolation and weighing of an element or compound of an element in pure form as possible. During last lecture, we have seen common ion effect. Common ion effect means when to a weak electrolyte, another electrolyte containing common ion is added, then degree of dissociation of that electrolyte is suppressed, and that is the common ion effect. For example, acetic acid is weak electrolyte, is dissociate as H plus and acetate minus, that is CH3COO minus. If another electrolyte just like sodium acetate is added to this solution, it dissociates as Na plus plus CH3COO minus. Hence, degree of dissociation of weak electrolyte is suppressed when another electrolyte containing common ion is added. All these things we have discussed during last lecture. We have also discussed ionic product and solubility product. Ionic product is the product of ionic concentration in an unsaturated or saturated solution. Product of ionic concentration in saturated solution or unsaturated solution, and that is called ionic product. We have seen solubility product. Solubility product is in a saturated solution of sparingly soluble salt. The product of ionic concentration when raised to proper power is constant at constant temperature. Hence, in case of solubility product, we consider saturated solution, and in case of ionic product, we consider saturated as well as unsaturated solution. Now, when ionic product is greater than solubility product, in that case only precipitation is going to take place, because in that case solution is supersaturated. During last lecture, we have discussed CoPrecipitation and PostPrecipitation. CoPrecipitation is the contamination of precipitate by the substances which are soluble in mother liquor, that is called as CoPrecipitation. Means, for example, adsorption of silver acetate over silver iodide, that is the example of CoPrecipitation. In CoPrecipitation, the impurities are soluble in mother liquor, but when precipitation takes place, they are going to precipitate along with main precipitate, and that is called as CoPrecipitation. Another contamination of precipitation is called as post-precipitation. In case of post-precipitation, precipitation takes place after some time or after formation of the main precipitate. The process in which precipitation of some component or impurities occurs on the surface of main precipitate after its formation, and that is called post-precipitation. For example, during formation of calcium oxalate, magnesium oxalate can form afterwards. All these things we have discussed during last lecture. Now in today's lecture, we are going to see the different factors that affect the solubility of precipitate. Then we are going to see precipitation from homogeneous solution, different operations that are involved in gravimetric analysis, and finally we are going to see some organic precipitants. Learning objective of this session: at the end of this session, students should be able to understand various factors that affect the solubility of the precipitate. They should be able to understand the technique of precipitation from homogeneous solution. They should be able to understand various operations that are involved in gravimetric analysis, and they should be able to understand how to use organic precipitating agent for getting precipitate. Now, first point we are going to discuss in today's lecture, that is factors affecting precipitation. First factor that affect precipitation is Effect of acid on solubility of precipitate. In general, similar to salt effect, solubility of sparingly soluble salt increases on addition of acid. Hence, when acid is added, the solubility of precipitate is increases, and that can be explained on the basis of this reaction. Now consider the sparingly soluble salt Ma. Ma dissociate as M plus A minus. When strong acid like HCl is added, HCl dissociate as H plus and Cl minus. H plus from acid combine with A minus of the salt to form undissociated Ha. In this case, as number of A minus ion in solution decreases, dissociation of Ma increases to produce more number of A. Thus, there is increase in the solubility when acid is added to the solution. Now, another factor or second factor that affect the solubility of precipitate, that is effect of the solvent. These are some point. First point, polar solutes are more soluble in polar solvent, while non-polar solutes, they are less soluble in polar solvent and they are soluble in non-polar solvent. Generally, inorganic salts, they are soluble in water because they are polar, while organic compounds are soluble in organic solvent. Hence, solubility of the precipitate can be controlled by using suitable solvent. Third factor, effect of temperature on solubility of precipitate. This is the figure which show how that temperature affect the solubility of precipitate. If temperature increases, solubility of precipitate also increases. Dissociation of the salt is endothermic process. Hence, solubility of precipitate increases if we increase the temperature. For example, solubility of silver chloride at 10 degrees Celsius is 1.72 milligram per liter. And if we increase the temperature up to 100 degrees Celsius, then this solubility increases up to 21.1 milligram per liter. Hence, as the temperature increases, solubility of these precipitate increases. Another example, solubility of barium sulfate at 10 degrees Celsius is 2.2 milligram per liter, but at 100 degrees Celsius it is 3.9 milligram per liter. Hence, solubility increases as temperature increases. Now, another point we are going to discuss in this lecture is precipitation from homogeneous solution. Homogeneous precipitation is the process by which precipitate is formed within a solution. Means in this case we does not add the reagent directly, but that reagent which is responsible for formation of precipitate is generated within the solution. Precipitating agent is not added directly but slowly generated by homogeneous chemical reaction that is taking place within the solution. Precipitate formed by homogeneous precipitation is highly pure. Now, the example of this homogeneous precipitation, urea is used for generation of hydroxyl ion, which is precipitating agent. It can be used for formation of precipitate with metal cation like Al3 plus, Fe3 plus, etc. This is the reaction. In this reaction, it is shown how that OH minus is generated from urea. Urea, that is CONH2 twice, it is added in water, and there is formation of carbon dioxide gas, there is formation of ammonium ion, and there is formation of OH minus ion. Hence, OH minus ion is slowly generated within the solution. If your solution containing Al3 plus or Fe3 plus, then this metal cation can combine with this OH minus and there is formation of the precipitate. In this reaction, it is shown Al3 plus that combine with 3 OH minus and there is formation of AlOH thrice as a precipitate. Now, another example of homogeneous precipitation, use of sulfamic acid for generation of SO4 minus, that is sulfate ion. Sulfanic acid, when dissolved in water, there is formation of NH4 plus, that is ammonium ion, H3O plus, and there is formation of sulfate ion. Now this sulfate SO4 2 minus can combine with Ba2 plus minus 2 plus Ba2 plus, and there is formation of BaSO4 as a precipitate. This is the homogeneous solution. Remember again, in homogeneous solution, the precipitating agent is generated within a solution due to some chemical reaction. In case of urea, when it is dissolved in water, there is formation of hydroxyl ion, and this hydroxyl ion can be combined with the metal ion, and there is formation of metal hydroxide as a precipitate. In case of sulfamic acid, it is responsible for generation of sulfate ion. Sulfate ion can be combined with Ba2 plus, and there is formation of BaSO4 as a precipitate. Now, these are some operations that are involved in gravimetric analysis. First operation is precipitation. In gravimetry, we want to prepare precipitate. Then second operation is called digestion. Third operation is filtration. Fourth is washing. Fifth, drying and ignition. Sixth is weighing, and seventh is calculation. We are going to see all these operations in detail. Let's see first one, precipitation. Say for example, we want to precipitate Ag from AgNO3 solution. If AgNO3 solution is there, and if we add chloride ion in that solution, then Ag plus can combine with Cl minus, and there is formation of AgCl as an precipitate. This is the method in that precipitation formation is shown. Another reaction, Pb2 plus, if it is present in solution, if we add chloride in that solution, then Pb precipitate out as PbCl2, and further it can be used for another operation. Second operation is digestion or Ostwald ripening. Digestion is the process in which that precipitate is allowed to stand for several hours, generally 10 to 24 hours with mother liquor. Sometimes this precipitate is warm with that mother liquor, and that is also called as digestion process. Then in digestion, dissolution of smaller particle and formation of larger particle take place. When we allow to stand that precipitate for several hours, the smaller particles of precipitate undergo dissolution and formation of larger particle is going to take place. It is useful for reducing CoPrecipitation. Remember again, digestion is the process in which precipitate is allowed to stand with mother liquor for several hours, generally 10 to 24 hours. Sometimes it is warm with that mother liquor. Third operation is filtration, separation of precipitate from mother liquor, that is called as filtration. There are different filtering tools that can be used. First is filter paper. Generally filter papers with low ash content, they are used. These are called as ashless filter paper. Sometimes we use hardened filter paper when very acidic solution or basic solutions are present in mother liquor. At that time, normal filter paper is not useful. In that case, hardened filter paper is used. It has resistance to acid and alkali. Another filter paper that can be used is Whatman filter paper. There are number of Whatman filter papers available. Whatman filter paper number 40 and 42, they are used for filtration of fine particle, whereas Whatman filter paper number 41 is used for filtering gelatinous precipitate. Another filtering media, that is a filter pulp, it is prepared by vigorously shaking and ordinary filter paper with hot acidic solution. The material which is obtained, that is called as filter pulp, and that can be used for filtration of the precipitate. Another is filtering crucible. Some precipitate cannot be filtered by simple method. These precipitate are easily undergo reduction and decomposes on heating. For such precipitate, filtering crucibles are used. These are some filtering crucibles: Gooch crucible, platinum Gooch crucible, silica Gooch crucible, sintered glass crucible. These are the methods which are used for filtration, and filtration is the technique in which precipitate is separated from the mother liquor. Another operation that involved in gravimetry, that is washing. Washing of the precipitate is very important, and selection of washing liquid is also important. During washing, there should be no loss of precipitate, because in some solvent that precipitate may be soluble, and if it is soluble then there is error in analysis. All these things we should remain, or we should consider before washing. First thing, that is solution which prevent the precipitate from becoming colloidal. Washing of precipitate removes the impurities which are present on the surface of the precipitate. Choice of washing liquid depend upon the type of precipitate. Generally, gelatinous and curdy precipitate, they are washed with the solution containing electrolyte, or they can be washed with the solution containing dilute acid. For example, precipitate of oxide of aluminum or oxide of iron, they are washed with 1% ammonium nitrate solution. Solution which reduce solubility of precipitate. When precipitate is soluble in washing liquid, then its solubility is reduced by using mixture of the solvent. For example, precipitate of calcium oxalate is washed with dilute solution of ammonium oxalate. And third thing, or third case, solution that prevent the hydrolysis of the salt of weak acid and base. Sometimes when precipitate is formed and when it is washed with solvent, hydrolysis of that precipitate can take place. To avoid this, these things are important. For example, addition of acid to washing liquid will prevent hydrolysis of ferric or similar salt. Next operation, that is drying and ignition. First of all, you should understand what is the difference between drying and ignition. When we heat the precipitate up to 250 degrees Celsius, it is called drying operation. And if we heat the precipitate above 250 up to 1200 degrees Celsius, and that is called ignition. Precipitate is heated until constant mass is obtained, and heating is essential for removing solvent and other volatile species which are associated with that precipitate. Another operation, that is weighing and calculation. Accurate weight of the completely dried precipitate is taken and used for the calculation. And how that calculation is carried out, here one example is given. Calculation of Ag from AgCl. Suppose we want to find out amount of Ag which is present in the solution. For that purpose, we have to add chloride ion in that solution. Ag plus combined with Cl minus ion, there is formation of AgCl as a precipitate. After drying of AgCl precipitate, weight of that AgCl precipitate is taken, and from weight of that AgCl we can able to find out how much Ag is present in that solution. For example, molecular weight of AgCl is 143.32 and molar mass of Ag is 107.86. If weight of precipitate is 0.5 gram, then weight of Ag can be calculated as 10.86 into 0.5, that is divided by 143.32, and the answer is 0.372 gram of Ag. Hence, in 0.5 gram of AgCl precipitate, 0.372 gram of Ag is present. In this way, you can able to calculate how much amount of that metal ion is present in that solution from the weight of that precipitate. Now, fractional precipitation. Precipitation of one component in presence of other component is also possible, and that is called as fractional precipitation. Example, when AgNO3 is added to the solution containing chloride and iodide, selective precipitation of AgI can be achieved by using the solubility product concept. Solubility product of AgCl is 1.2 into 10 raised to minus 10. Solubility product of AgI is 1.7 into 10 raised to minus 16. Thus, AgI is less soluble than AgCl. Hence, when precipitation is going to take place, AgI going to precipitate out first, and after that AgCl is going to precipitate. Hence, by adding proper reagent, we can able to precipitate out AgI only in presence of AgCl also. Now, another part of this lecture is organic precipitants. Organic precipitants are the organic reagent that are used for precipitating of various metal ions. They have the ability to coordinate with many metal ions as they contain acidic or basic group having unpaired electron on heteroatom. They have high molecular weight. Hence, small amount of metal can produce large amount of precipitate. Hence, taking weight of that precipitate is become easy. These are some features of organic precipitant. Remember again, organic precipitants are the organic compound that are used as a precipitating agent. They containing acidic and basic component or acidic and basic group. That's why they can coordinate with variety or majority of metal ion, and metal ion can be extracted by using this type of complex. Many of organic precipitants are selective. Selective means they are used to precipitate out only single metal ion in presence of other metal ion. By controlling pH and concentration of masking reagent, the selectivity of organic reagent can be enhanced. Let's see the example of some organic precipitating agent. First is 8-hydroxyquinoline. It is also called oxine. This is the structure of 8-hydroxyquinoline. Hydroxy group is present at 8 position. Quinoline is the parent structure. Its molecular formula is C9H7ON. By controlling pH, it can be used for precipitation of many elements. It forms C9H6ON twice type of complex with Mg2, Zn, Cu, Cd, Pb metal, because all these metals are bivalent and hence this type of complex can be formed. It can form complex with aluminum, iron, etc. also. It can form complex type MC9H6ON 4 time with zirconium and thorium. Now, how the reagent of 8-hydroxyquinoline is prepared? 2 gram of 8-hydroxyquinoline was dissolved. 2 gram of 8-hydroxyquinoline was dissolved in 100 ml 2 molar acetic acid, and dropwise ammonia solution is added in that solution till turbidity persists. After formation of turbid solution, few drop of acetic acids were added to get clear solution, and when this solution of 8-hydroxyquinoline is used to extract that metal ion, in this case M2, it may be Ca2 plus, Mg2 plus, like that. 2 moles of 8-hydroxyquinoline combined with M2 plus, and there is formation of metal complex. Hence, this complex can be filtered out, and we can measure or we can take the weight of that precipitate to find out how much amount of M2 plus is present in that solution. Another organic precipitant is dimethylglycine. In short, it is called DMG. This is the structure of DMG. 2 hydroxyl groups are present. Molecular formula is C4H8O2N2. 1% solution in ethanol is used as a reagent. It forms bright red colored complex with nickel metal, that is complex is NiC4H7N2O2 twice. Hence, Dimethylglycine is specially prepared for the extraction of the nickel metal from the solution. It can form complex with nickel metal easily. This is the another reaction that is showing how that nickel is extracted by using that 2-hydroxy extracted by using dimethylglycine. This is the complex which is formed. Another reagent that is used in gravimetry, that is Keferon, ammonium salt of N-nitroso N-phenyl hydroxyl amine is called Keferon, and it is generally used for extraction of Fe3+. This is the structure, and its molecular formula is C6H9N3O2. 5 to 10% acidic solution is used as a reagent. It is specially used for determination of Fe3+. It also used for determination of vanadium 5, titanium 4, zirconium 4, cerium 5, and that is the structure that's showing how that complex is going to form with that Keferon. Iron and Keferon, they combine together to form this type of complex, and this complex can be filtered, and from the weight of that complex or precipitate, the amount of Fe3+ which is present in the solution can be calculated. Nitron is the another organic reagent. This is the structure. Its molecular formula C20H16N4. It is yellow crystalline solid. Melting point is 189 degrees Celsius. 10% reagent in 5% acetic acid is used as a reagent. It is used for determination of nitrate and other anion. Keferon, that is benzoin alpha oxime, is the another reagent, organic precipitating agent, which is used in gravimetry. This is the structure, and its molecular formula is C14H13O2N. It is white crystalline solid. 2% solution in ethanol is used as a reagent. It is specially used for copper. With copper, it forms green complex, that is Cu C14H11O2N. This is the molecular formula of that complex, which is obtained by using Keferon and copper. Color of this complex is green complex. We have discussed various techniques of gravimetry. Based on this, you have to solve this question and send them on my Google Classroom. First question is, explain the precipitation from homogeneous solution with example. We have discussed homogeneous precipitation with example. Homogeneous precipitation is the precipitation which is formed within the solution. Reagent is not directly added to the solution, but it is generated within the solution, and it combined with another metal ion to form that complex type or precipitate material. Another question, explain the different operation involved in gravimetry. There are different operations just like precipitation, then filtration, drying, ignition, washing. All these things are very important, and calculation is very important. You have to write all these things. And third question, what is organic precipitant? Organic precipitants are the organic compounds that are used for precipitating out the material. Organic precipitants are the compound which containing acidic as well as basic group, hence they can form complex with variety of the metal ion. Hence from that weight of that complex you are able to find out the metal which is present in that solution. Summary of today's lecture. We have discussed various factors that affecting the solubility of the precipitate. We have seen effect of acid, we have seen effect of solvent. Then we have discussed homogeneous precipitation. We have discussed several operations that are involved in gravimetry, and finally we have seen some organic precipitating agents. Now recap In next lecture, we are going to see the applications of gravimetry, and we are going to see some numerical problems based on gravimetry. Thanks.